Hello everyone. So we are given the values of x and y, and we need to show that y square into d square y upon dx square minus x into dy by dx plus y equals to 0. So is given as a cos theta plus b sin theta. So we know when we differentiate cos theta in terms of theta, it becomes minus sin theta, and when we differentiate sin theta in terms of theta, it becomes cos theta. So basically we differentiate x with respect to y. So a cos theta becomes minus a sin theta, and b sin theta becomes b cos theta. Similarly, y is given as a sin theta minus b cos theta. On differentiating it with respect to theta, we get a cos theta plus b sin theta. So taking the ratio of dy by dx, which is a cos theta plus b sin theta upon a sin theta plus b cos theta, we get minus x equals to y by comparing it with the previous values of x and y as we have been given it in the question. So solving these, we get y dy by dx plus x is equals to 0. Now in this equation, we apply the product rule on these two terms. So we can take it to be a, and dy by dx we can take it to be b. So here applying the product rule on a and b, first we differentiate a and multiply it with b, and then a multiplied by derivative of b. So here what we have done is we have taken y as it is and differentiated dy by dx with respect to x, so it becomes d square y upon dx square, and then we have taken the term b, which is dy by dx as it is, and then we have differentiated y with respect to x, so it becomes this. So it is of the form a b dash plus b a dash, as I have discussed it here in the product rule. And x, when we differentiate it, it becomes 1, which equals to 0. So this is our equation 1. So when we further solve the equation, taking the values on the left hand side, we get this equation. And finally, when we multiply this equation with y, we get y square into dy square upon dx square minus x into dy by dx plus y equals to 0, which is our required answer. Thank you.